Okay, Assalamualaikum and hello. Okay, welcome back to the class. Okay, today we continue with the chapter 1B, which is three-phase system. So if you check back the course information here, okay, you can see it should be week 3, but actually we have to do it quickly because this schedule is not ideal. Okay, because it ends at week 15. It is very close. Okay, because we have to do some discussion on the test and everything, so we have to do it quickly. So if you look at week 3, we will learn about three-phase system. Okay, three-phase system. Wait. Okay, so let me share screen. Okay, so here are week 3. Okay. So we will start with introduction, balance YY, balance, and everything. Everything here we will discuss. So maybe I just go through some of it. Okay. So what is three-phase system? Okay, first you have to look at the notes. Okay, I give you this one, so you can look at the 1.2.1. Okay, or you can use the textbook 1.2. Either way is almost the same. Okay, so so of course you will understand the three-phase concept, different parameter of star delta. Okay, why is star? Delta is three-phase triangle. Okay, so analyze the balance phase. So you will have two parts. Okay, the first part is balance, and the next part is unbalanced. It means that balance means balanced load, means that all of three-phase, all the load is balanced, the same. Unbalanced means that the load is not the same for all three-phase. Okay, so a little bit of theory. Okay, what is three-phase circuit? Okay, what is the advantage? Okay, basically most of the electrical system generated are three-phase. Okay, basically even in your distribution system, it's also still a three-phase system. Okay, so the power of instantaneous power in the three-phase system can be constant. Okay, the amount of power for the three-phase is more economic than the single phase. Okay, if you use three-phase, this is why we use three-phase, because the amount of wire is less than if you use single phase. Okay, basically three-phase only require 3 to 4 wire only. But if you do use the single phase, it's basically more than that. Okay, you have 2 wire, but because of these 2 wire, you have three wire components, so it will become 6. Okay, but the important thing, this one, okay, because wire is quite expensive, so if you can reduce the number of wire, it is very good. That's why we use a three-phase system. Okay, what this mean by three-phase? Okay, basically you have 3 sources. Okay, 3 alternating, okay, AC power source. Okay, and you connect it together. Okay, either star or delta. This one is a star, but the phase, okay, remember this one is important in three-phase system. The phase is different 120 out of each other. Okay, so this is the important part. So basically, if I draw the phase, okay, so assume that you have a red wire. Okay, this is 0 degree VA, 0 degree. Okay, and then you have another wire here, yellow. Okay, and then you have another wire here, blue. Okay, VC. Okay, so basically this one is 120 degree, 180 degree, and 120 degree, sorry, and this one is 120 degree. Okay, why 120? Because 360 divided by 3 phase. So you get 120 degree different. Okay, so that is the reason of the 120. So you have 3 voltage source that has different phase. Okay, so what it means that, assume that you have power supply, something like this. Okay, connected together. Okay. Okay, so you have, example, this one, your VA is VM, or okay, just VS, okay, equals VS angle 0 degree. Okay, for this one, okay, VB is equals to VS, okay, angle 120 degree, negative 120 degree. This one, VC is VS angle positive 120 degree. Okay, and one more thing you need to know, positive 120 degree, negative 120 degree is actually equals to 240 degrees. So you have to recall back that the angle. Okay, remember you have negative 120 is actually 240. Okay, so only the phase has different. The magnitude still the same. Okay, the voltage magnitude for all 3 phase is the same. Okay, this one is important. Okay, and okay, this one is the textbook. If you want to use the textbook, the content is almost the same. So basically, this is how you get a 3 phase. Basically, you have 2 wire. Okay, this one is 1 voltage source, 1 voltage source, and 1 voltage source. That is how you get 3 phase from a generator. Okay, so it's something like this. Okay, so as I mentioned before, the connection can either be star, this is star connection, or Y, okay, Y connection, star or Y connected. This one is delta, okay, you look at here is triangle. Okay, so, and this is the voltage I mentioned about. Okay, the voltage source here is either can be phase, okay, is 0 degree, negative 120, negative 240, or positive 120. Okay, make sure you understand the voltage. Okay, you can see here VP is all the same, voltage magnitude is the same, only the phase is different. Okay, that is mean by the 3-phase system. Okay, you can see here. Okay, you need to know how to draw everything. Okay, so today I will introduce you on how to draw the circuit. Okay, so before I forget, let me show you here. Okay, this one I already show you. Okay, sorry, my PC hang again, so I need to open back. Okay, so remember that I said that I can be either star and delta. Okay, if you look here, okay, so it can be either star, okay, this one, okay, this one is delta. Okay, let me draw this. So this is delta, okay, delta or something like this. Okay, or you can use star. Sorry, okay, make sure you understand the star and delta, how to draw this. Okay, okay, let me. sorry, my PC is not responsive. Okay, let me pause. Wait, I pause because my PC is not responsive right now. Okay, so okay, you have here is delta, you have here is star. Okay, so this is star, this is delta, star is y. Okay, you can call it either delta or triangle. Okay, this is for the source. Okay, and of course this one is also applied for the load. Okay, for delta load is something like this. Okay, okay, this one something like this. Okay, and don't forget, okay, use for impedance Z. Okay, you use this symbol. Okay, this represent impedance. Okay, and this one for the star. Okay, so this is load. So you can see here, you can either you have a source delta source star, source load delta load star. Okay, so it is the possible condition here. You can see here YY means that you have a star load star source. Okay, so if you okay, this is okay. The first part is the source. Okay, what happened? Okay, basically the first one, okay, maybe I just show you here. Okay, the first one is the source, the second one is the load. So YY means that you have star load, star source, a source star load. Okay, Y delta, star delta, okay, this is star delta. Okay, the second one is the star delta, means that you have a source connected to star connection, and you have delta, you have load connected to the delta connection. This one is the delta. And then you have the delta means that the source and the load has delta connection. And last one is the star, delta star, means that your delta, the first one is the source, delta, and the second one is the load, the star connection. Okay. So usually for the step down, we use delta star delta, and for the step up we use delta star. Okay, so this one, make sure you understand what is mean by delta star, star delta, delta delta, star star. Okay, so which one is the source, which one is the load? Okay, try to understand this. Okay, this is the configuration. Okay, you can see here star star, star delta, delta delta, delta star. Okay, one more thing, although this is, I said here, there are 4 possible connection for star-star connection. Okay, star-star connection. Okay, it can be either 3-wire or 4-wire. Okay, you can either have 3-wire or 4-wire. So remember that. Okay, what it means by 3-wire. Okay, 3-wire, you can see here the main one, YA, IB, and IC. And the 4th wire is the neutral wire. Okay, so neutral wire can be, you can have it or not. Okay, okay, if you have a balanced load, you don't have to put a neutral wire. But in the real world, there will be no balanced load. Okay, that one will be discussed on the next subtopic. Okay, unbalanced load. unbalanced three-phase system. So that one, you can see what is the difference between with wire and no wire of the neutral. Okay, this one is the neutral. So basically, you just add a wire here, okay, or here. Okay, so basically, star can have either neutral wire or with neutral wire, without or with neutral wire. Okay. So another important thing that you need to know is phase sequence. Okay. Phase sequence, you can see here. Okay. Make sure you know how to differentiate phase sequence. Okay. You can either have positive sequence or ABC sequence, or another one is, let me write this. Another one they call is RYB. Okay, red, yellow, blue. Okay. Positive sequence, ABC sequence, RYB, or negative sequence, ACB sequence, or RBY. Red, blue, yellow. Okay, make sure you understand you memorize this positive sequence and negative sequence. Okay, what it means that, okay, make sure on positive sequence, you can see here, A is the same. Okay, let me change this. Okay, if you can see here, A is the same. You have 0 degree, okay, 0 degree, okay. But for the B and C, it is different. For positive sequence, we move to the negative 20, negative 240. So basically, you move down, or you move clockwise. Okay, positive sequence is basically, okay, clockwise. Okay, ABC means that it is clockwise. But this one, it's, if you can see here, ABC is counter. Okay, so make sure you know. Okay, you know the difference. Okay, if you use positive sequence, means that VABC use clockwise. If you use negative sequence, the ABC is counterclockwise. You can see here, VA is 0, VB is 120, VC is actually 240. Okay, although this is a simple thing, but this one is very dangerous. Okay, if you put the wrong sequence, your system can destroy. Okay, can be broken. Okay, so make sure you know the positive sequence and negative sequence. Okay, another, okay. Okay, determine the phase sequence. Okay, so I give you an example here. You can see here VABC, ABC. Okay, VABC, you can see here 200, of course, the magnitude is the same. And 40, negative 80, 120. So you can see here it moves towards the clockwise. Means that this is positive sequence. Okay, why? Because from A to B, it's moved towards negative. From B to C, is moved much more further towards negative actually. So this one is actually negative 200. Okay, so make sure you know how to convert positive 120 to this one. Okay, and how about this? Okay, if you look here, ABC, make sure the sequence is ABC. Okay, then you look 110. Okay, this one is positive. Okay, 110. So means that your phase is clockwise. Means that this is counterclockwise. I mean, okay, counterclockwise means that, okay, your system is negative sequence. Okay, so make sure you understand how to do this. Okay, if you still confused, make sure you change this. Okay, so negative 130 is actually 360 minus 130. So you get 260 degree angle. Okay, this one is a balanced three phase. Okay, balanced loads. Okay, if they said balanced three phase system, means that it means by load. Okay, your load is balanced, means that the Z for each phase is the same. Okay, now this is the calculation. Okay, so for calculation, we wait for it. Okay, I want to show you how to draw first. Okay, so this one, draw and label. Okay, the confusing thing about doing a three phase is the labeling. It's quite it's a bit tricky actually. So let me show you star connection first. Okay, sorry, my PC hang again. Okay, okay, so to draw the star connection, of course, okay, with neutral wire. Okay, with neutral wire. So of course you use this, use this, use this. This is star. Okay. Okay. So now, okay, one more thing for the sequence, we always use positive sequence. Okay. Always use positive sequence. Okay. For negative sequence, you need to know, but we don't use in the class. Okay. For negative sequence, you have a little bit different calculation. That's why we only focus for positive sequence. Okay. So remember V A N V Y N. Okay, remember this is N, this is A, this is B, this is C. Okay. Okay. How to remember is A usually at the top, B is always internal, go inside, and C is outside. Okay, outside the screen. Okay. Okay, the center one is the neutral wire. Okay, if you without. Okay, how about without? Because we want to avoid more confusion, so we just remove the neutral wire first. So this is how you label it. Okay. How about the star? Okay, you have this one. Okay, if you look here, not the textbook, this one is not the note. Okay, I think there is something wrong. Okay, this one, so you have to be careful. This one is not follow the standard. Okay, so try to avoid crossing. Okay, make sure you be inside. Okay, remember that I said, okay, top always A. Okay, at the center is B, and at the outside is C. Okay, this one is important. Okay, how about the current? Okay, so for the current, always goes from the source to the load. This one is IA because it is A from A. This one is IB. This one is IC. Okay, so that is how you draw the current. And how about the voltage? So the voltage, remember, okay, voltage, you can either use arrow or positive, negative, okay, for the voltage. Okay, so this one is VAN plus minus VBN minus at the end, okay, plus, okay, this one is minus VCN. Okay, so try to understand how to label this. Okay, this one VAN. Okay, this is neutral. VCN. Okay, this one Okay, if you want to use positive negative, just keep to positive negative. Okay. Okay, VBN. Okay, that is how you label the drawing. Okay, make sure you label the current and the voltage. Okay. So I think that's it for the introduction. I will repeat this back for your next session. Okay, that's it. So we continue with our next